welcome. Another great session tonight for you. This is Dalim, who's chair of two great groups, BCS North London branch and BCS Central London branch. And I have a number of colleagues to introduce you to, and then I'm going to hand over. So which colleagues do I have with me? Well, I have my good friend and the secretary of London Central branch, David Grundy, who I'm going to hand over to in a minute. And he, as usual, will handle the recording and packaging of the video resulting from this session. He will also work on the questions, the Q&A, because I'm hoping you'll be sending in questions and asking lots of good things of our speaker, Ron Ballard. But we also are privileged to have Dan from West Yorkshire with us as well. Dan is the chair of West Yorkshire, and we are, of course, collaborating, as you'd expect, for good BCS groups. Now, there are probably more than 100 other BCS groups, and so if you're in one of those, I encourage you to come and collaborate with us for future webinars. But for this one, we're going to get agile development, and talk about relational databases. And our expert today is Ron Ballard, but my person that I'm going to hand over to right now is David Grundy. David, over to you.
Hi there, everybody. Thanks for joining us. So our speaker tonight is Ron Ballard. Ron graduated in computing from Manchester University in 1973 and spent 15 years working for database vendors after the British Library. From 1996 to 2017, he was an independent database consultant working with big databases in large organizations. Ron has since retired, but in 2017, he published his book, Relational Databases for Agile Developers, explaining how well relational databases can work with agile development practices. Ron has previously spoken for us on the topics of blockchain and data management, and his talks generate a lot of discussion. So if you have any questions for Ron, then please type in the chat and we will come to them later. And Dan Toms, the chair of West Yorkshire, will handle the questions at the end. So over to you, Ron.
Hello, right. Thank you very much all for coming, and thanks to all these good people who've made all this happen magically. So yeah, I'm going to talk about building data warehouses and using an agile approach to do that. I've been working on data warehouses for most of the last 25 years. I've done some other bits and pieces as well in between, but it always seemed to come back to data warehouse projects. And so what I want to talk about today is a kind of the point we've come to where we've had a few really good successes, and we've tried to consolidate that into a way of working now, which I'll try to describe. You'll see this picture on the front a few times. I'll explain what that means, but it starts off with, if we get to the next slide. There we go. Operational systems. These are the systems that feed into data warehouses, and they're the things that keep businesses, charities, public sector organizations running. Ralph Kimball, who's one of the big names in data warehousing, describes the databases behind the operating systems as twinkling databases. So I tried to capture that here. Hopefully you can see that now. Because most of the data sits in that database and doesn't change. But people are working with it all the time and adding new records and changing existing records, hence the twinkling. So let's explain what a data warehouse is and why you would want one. Most places I've worked have multiple operational systems, from 2 or 3 up to well over 20 in some cases. And many of those will have some elements of similar data in them. So a customer would be an object that you'd have in your database. And if you look at on the top part of the slide, let's say that those triangles, those red triangles, are the customer in the different systems, and they're all slightly different colors because each system describes a customer in its own way, and they'll overlap a lot, but they'll organize the data about a customer in different ways. So what we want to do is in the data warehouse, is to bring all that together and have one view of what the customer is, which is a superset of the useful information we have about customers, but also a standardized version so that there's no argument about the different address formats. They all get put into one particular address format in the data warehouse. So the operational systems, their databases are specific to the applications, specific to those particular systems. What we want is an organization-specific and application-neutral database that we can use throughout the whole organization. Traditionally, going back a long time ago, data warehouses were used for reporting and consolidating data across all the operational systems. And the reason was that if you did that kind of processing on your operational systems, you'd slow them down. You run a big report and it would slow down the operational system and people get bad response time. That's not so bad now because systems are so much more powerful than they were. Data warehouses have also been used for collecting, cleaning, and restructuring data from old systems, either to build a new system using existing data, or to import that existing data into a packaged solution. If you just try and import it from all the different operational systems, you've got a real mess and a lot of work to do. So this cleaning function is quite often something that the data warehouse is asked to do now. There are some assumptions about data warehouses, some of which are historical and most of which linger on a bit, but the emphasis has changed, I think. So people talk about temporal databases, which really means they keep some sort of history or audit trail of something. And a lot of operational systems do that as well now. But the data warehouse has the opportunity to build history where there isn't history in the operational system, because it will typically load data from each operational system every night. Depends on what your organization does, but typically it's overnight. And so it will get yesterday's picture of what that data was, and it may be different from the day before. And if the operational system only keeps the latest version, well, the data warehouse can collect the versions over time and keep a history of when they change, which can be useful. So that is, all systems are temporal, but data warehouses have this opportunity to add to that. Aggregation. So again, when disks were much smaller and databases were much slower, dealing with the detailed information in an organization could be very slow, and it could take up a lot of space. So data warehouses used to keep aggregates, monthly summaries of transactions or daily summaries of transactions or something, to keep the volume down and to still be able to do the reporting. These days, nobody wants that, because what people really want is to have all the data available and to be able to go and explore it. And insights is the big word, of course, but actually getting insights out of it can be a bit tricky. But if you've got all the data and you've got tools that can let you explore all of it, then you're going to have much better insights. So everybody wants detail now, and I haven't seen a data warehouse that was just aggregates for years. Another assumption is that it will be a star schema or a collection of star schemas. I'll just explain briefly what this is. So a star schema has what's called a fact or a measure table in the middle, which has some measures. This is from a car insurance company that's one of the earliest ones to put a box in the car to measure where the car was and how fast it was going and what the acceleration was and all that kind of stuff. So the measures would be the number of meters since the last point, and they did measure it in meters, and the number of seconds since the last point. It might be fractions of a second. And then, so those are the measures at the bottom of that driving points fact table. And then the rest is a bunch of foreign keys which point to the dimensions. And if you think about the sort of reports you might want to do, you might want to go and look for a particular car. So you could do that through the vehicle. Look at that dimension and then go and find all the points in the fact table for that. Or you might want a particular make of car. You know, is this car having more accidents than other cars? You might want a date range, so you look at your calendar. You might want time range within that, so you look at the time of day dimension. So notice that these are dimensions, and you don't have the date and the time in the fact table. You have them in dimensions so that your queries can come in from the dimensions to the fact. It's a very elegant way of doing it, and it's what is also called dimensional modeling, and that's what Ralph Kimball was most famous for. The other famous person is Bill Inmon, who actually I find I'm working more in the way that he suggested these days. We'll come on to that in a bit, although I find his books completely unreadable and Kimball's brilliant, really nicely explained. But anyway, it's good to know about star schemas because they may be useful in your system, and it is a neat idea. It makes it very difficult to get your reports wrong in terms of the aggregates, because that dimensional structure forces you to collect only the data that belongs to that combination of dimensions. But the problem with the star schema is that it assumes in the design, it's assuming a set of queries that you want to do. And most people want to be able to do, most organizations want to be able to do completely unlimited. They don't want to have predefined sets of queries they can do. They want to be able to do anything that the data can tell them. And star schemas also have a tendency to drift from that elegance by having two facts with the same sets of dimensions, or more than two. If they've got two, they're called bipolar schemas. And then Snowflake schemas is where the dimension isn't quite, hasn't got enough structure in it. It's a flat structure, and you want some structure, so you build other tables around the dimensions. So that's called a snowflake. I think the Snowflake database system is kind of referencing this, but they are two different things. There's a database system called Snowflake, and there's a Snowflake schema, which is a kind of messed up star scheme. The other problem with star schemas is that some tools, such as Power BI is one I've come across, they try to make it very easy to navigate the data, and they don't really understand star schemas, so they get a bit confused, and you have to do it a different way anyway. Right, so that's a bit of how we got here. What people want these days in a data warehouse is all the data in detail, absolutely everything that's in the source systems, the operational systems. And you want it for reporting, and you want it for research and analysis and trying to dig into that data. And often you want it for migration to a new system. And my view is the data warehouse must be as simple as possible, and no simpler, of course. But I've seen some very complex designs, some very theoretical things with subtype hierarchies and all kinds of stuff. And really, you want to keep it as simple as possible so that people can use it for as many things as possible. And you need to be very reliable and need it to have good performance. And those are much easier than they used to be. But you can mess it up. I've seen a database recently that takes up 10 times as much space as our data warehouse with the same data, and takes 100 times as long to load. So you can mess it up, but you can also do it well. Now, you might say jaundiced. This is from experience of working with a lot of big vendor products, and actually with working for vendors and being in those sales meetings where they're saying, the sales director saying, so how much are you going to get out of this organization? No, I want more than that. And so data warehouse projects are big, because whatever the size of your organization, if you're putting all of your operational systems into one database, that's going to be a bigger system. And some of them can get very big indeed. And the big vendor salespeople, I think they have some kind of radar because they hear about this, and they've got lots of things to sell. Data modeling tools, common data models, which we'll talk about quite a bit. Data profiling tools, data wrangling is another thing for helping you clean up your data and understand what's wrong with it, fix it. Data integration tools, that they seem to be called that more than ETL now, or ELT tools. That's what they used to be. And quite often the data warehousing methodology. So the big project, big vendor approach is, I think you should try to avoid it. Perhaps if I give a little bit of background for that, I worked for a very big payment card organization, and they had 10 or 20 database designers, each with a huge monitor, each with a £6,000 database design tool. They spent 2 years designing the database, and they had an A0 printer as well, so with a roll of paper, so you could print wallpaper with it. And nobody ever used their model. 2 years work with all those people. So you need to be careful of that kind of thing. And it is true that those vendors who've got all those tools, they've got targets to meet. Their job is to extract money from your organization. Sadly, and this really is from experience, their solutions are generally more expensive, more complex, and less efficient than you can do the way we'll talk about now. So I find that a lot of organizations don't trust their own people. And they think that a big organization is naturally going to be better. And that's very often not true. So you can go wrong with a small team, you can go wrong with a small implementation partner, but some of the small ones, if they've got a good reputation and you check that out, you'd be better working with them. You'll get their best people. You won't get the ones that are just left after they finish doing all the sales meetings. And they really need, the people you work with really need to be able to communicate, whether they're your own programmers or database designers, or whether they're from an outside consultant. If you can't understand what they're saying, then don't employ them. So yeah, I mentioned the armies of strategy consultants, data models, enterprise architects, and designing this ultimate solution to end all solutions. By the time they get there, it's completely out of date. And then another thing that happens is, if you've chosen a data integration tool, there are people who specialize in that tool, in a particular version of that tool. They're terrified of you changing to another version so that their certification will run out of date. And you get stuck in that particular product. So I say don't do that. There you go. Right. So how you can do this in an agile way. And this is a pattern we've followed quite a few times, and especially although I'm retired, I'm volunteering now with a biggish UK charity, and this is exactly what we did. So they said they wanted a data warehouse because they're moving to a new CRM, and they wanted to get all their data together. And the old system's 25 years old. So first of all, we talk to the users and we find out what they use most. In this case, they have a lot of individual supporters, send them £10, £20 a month, whatever, for years and years. And they have a team that looks after those people. And so we went and talked to them and found out what it was that they do most. And then we asked them what it was they wanted to do, but they can't do at the moment. And one of the things was that they haven't got a decent search on the old system. You can search on the supporter's number, reference number, but if you're a charity donor, do you remember your reference number? I certainly don't. And then you can search on the name. Well, if you look up my surname in their system, Ballard is not that common, but you get 217 hits. So then you've got to find the right one. So they wanted a better way to search that. So the first thing we did was to find out where that data is. And it's in about the core of it is in about 3 tables in the old system out of, there's actually 1,000 tables, but an awful lot of those are completely redundant, but there are hundreds of useful ones. So we found 3 tables. So we got our database system for the warehouse, and we created a staging area, a schema in the database. And we created tables that were exact copies of the, in terms of structure, exact copies of the source system. And then we copied the source system data into the staging area. So that now is an exact copy of those tables in the source system. We then profiled it. I'll come back to profiling in a minute. We improved it in various ways, and then we built something that uses it. And we're using Postgres as our database. It's free. It's got, it's a good, solid, standard relational database. It's also got some really good text searching facilities. And I used it before in the insurance company because it's great. Got great mapping and geospatial functions in that. Anyway, so we built a little, first of all, we built a nicer structure of the data, and we indexed every word in every text field, which sounds quite heavy, 2 million contacts, but actually it runs, runs very easily in the window we've got overnight with all the other stuff. And we built a simple little web application which would let them search on anything, and they love it. So now we're started. And that's just the kind of, it builds confidence in the team that we can do it. It builds confidence in the users that we're there to help them. And then really I heard one Agile coach, really good guy who, very interesting talk. And he said, what we do is we have a point on the horizon. That's where we're going. And we're not going to plan the whole way through there. We're going to say, what can we do that will take us a step closer to that? And that's what we do in every day, in every iteration or Scrum or not Scrum. Every step that we're going to sprint, every sprint that we're going to do, whatever we're going to call it, every bit of work, we do something that gets us closer to that goal. So we really kind of repeat that. We keep talking to the users. Another thing I didn't mention here, but I will come back to, is that we document what we're doing as we doing it. We have a wiki, which now is 450 pages. And of course, that's 450 web pages. So that's bigger than 450 A4 pages of really useful documentation, things that some people knew how it worked. Some people, in some cases, nobody knew how it worked. And we worked with them to find out what it was doing. But all that stuff got documented as well as we're going through it. Now, of course, the traditional idea is that you have to build the data model first and get it completely right before you start building applications. That is not necessary. I know it's not necessary from experience. And in fact, if you build it incrementally, it will be better than one that you designed up front because it will be up to date. What you have to be prepared to do is to refactor it ruthlessly. So when you find out something which challenges a decision you made about the relationships between 3 tables or what columns should be there, then you restructure it, and you can easily write SQL scripts that will take one structure and turn it into another. That's what SQL does. So you have to be prepared to refactor it ruthlessly, and then you can keep it up to date. And actually, most things don't change. an individual supporter has a name and an address and some marketing preferences and an amount of money they give and how they give and whether they sign petitions, all kinds of stuff. But that stuff, not much of it is going to change. That core will be the same at the end as it was the first time you did it. So that's you mustn't be afraid of building an incremental data model. If you remember that picture from the beginning with all the geometric shapes, colored shapes. So what we did basically with this one was to take a bit of the supporter information and build that for our first one. And then we added a bit more for the next piece of work we did, and we added a bit more and a bit more and a bit more. And we obviously did a lot more steps than those few, but that's, you know, how the whole thing grows. Of course, by the time you get there, something new and shiny has come along, and you want to add that in, so you can do that too. And that model keeps on growing and keeps on being more representative of what the organization does in total. That's what we're aiming for with the data model. It should be a really precise representation of the objects that people use and the relationships between those and how they change, the processes that deal with them. Oops. So, yes, good. Right. And that data model is specific to the organization. There is no universal data model. If two organizations had exactly the same data model, I wonder how they'd probably merge, wouldn't they? I mean, every organization has to have something distinctive about it. And every organization's data model should represent that specific thing. And to get a common data model is it's missing the point, because it's not designing the data model that's hard. What's hard is understanding your organization's data and how it's used. So as the data warehouse team, you know, we have to go to the supporter contact people. We have to go to the fundraising team. We have to go to the campaigns team. We have to go to the finance team, loads of teams, and they're all experts in their field. And we've got to understand enough about that to build the database that represents it. And that bit is hard. But people are very willing, I found, to talk about how their stuff works and what's important to them. And so you can do that. Once you know how that works, building a data model is easy. And you can do it with parts of that data as well. And you can change it. So you don't have to worry about getting it perfectly right the first time. If you do, it'll still be wrong next month because something will have changed. And if you get a common data model, and I've seen a few of them now, then first of all, you still have to understand your organization's data before you start using the common data model. Then you have to cram your data into this data model and it doesn't fit. You damage it, you make compromises, you make workarounds. So that common data model is a hindrance, not a help. So don't buy one. I'm not the only person who says that. There's the woman who co-wrote a lot of Ralph Kimball's books, Margie Ross, wrote a really nice 3-page paper, I think, about why common data models are a bad idea. And that's about 15 to 20 years old now, but it's fresh, it's still true. I've said you have to be prepared to refactor it. And David Heinemeier Hansen, he's the guy who invented Basecamp and Ruby on Rails, and worked with Twitter when they were using Ruby, because that's how they got started. And he's very outspoken. So he says, if you're going to write an application backed by a relational database, you should damn well know how a relational database works. Unfortunately, a lot of people don't. And I think it's because there are some good courses now. I know some people have been on the BCS SQL course and they come out pretty good. But some of the older courses I saw and other places and some of the books were really heavy. The book that's most popular in the States, because the universities mandate it, is by a professor from one of the big universities. It's 1,600 pages long. It costs $100 or something. It's an expensive book, and it's really hard to work out. So one thing I wanted to do when I first retired was to write down what's important, what you need to know, and try and do it in plain English. And I've had some nice feedback. I hope I've succeeded. And so that's mine there. Another one I found that I really like is this Sql Anti-Patterns one, which comes at the problem from a different angle, but covers the same subject matter. And I do refer to this book quite often. He looks at things that people commonly do wrong in relational databases. Why did they do it that way? What are they trying to achieve? What's a better way of achieving it? What's the problem of doing it that way? What's the benefit of doing it the way he's saying? So that's a really good one. So there is stuff around to help people learn about relational databases, but you can't just pick it up and start typing. You do need to understand how it works, and then it's a very powerful tool. So building the data warehouse, and most cases they get built overnight, every day or every weekday, every weeknight. And the pattern is really very simple. We get the source data. It's usually in a SQL database or something that you can access using SQL, or something SQL-like, like Hive, for example. So you use SQL to extract the data, not doing anything fancy to it at this stage, just trying to get a clean copy of it and getting it into the staging area. Then you've got it in your favorite database, and you can use SQL to restructure it into the data warehouse. The old one that we're working on at the moment has what's called abstract data modeling, where you have lots of, in the database, you can define new fields and how they work together, and so you get this indirection level, which is really horrible. So we untangle all that stuff in the data warehouse, but that's really the process, just two kind of SQL things, and we repeat that every night. For most tables, and often for entire data warehouses, most organizations have less than a terabyte of data, and if that's your situation, then you can probably copy everything overnight. It's possible to do that. We do it in a few hours for 270 million records every night. And we drop the old one and recreate the new one in the staging area. We don't drop the warehouse. And then we use that new copy of the data to bring the warehouse up to date. If it's very big, then you can sometimes identify changes in the source system by a timestamp, if you've got a reliable one. If you haven't got one, then you might be able to put triggers in the source database to actually record the changes that happen. Give you a kind of, it might just be the keys. This key in this table changed last night, or the record defined by this key changed. And then to use a sledgehammer, you can do a difference calculation. You can do that in the server operating system if you're using Linux. You can do it in other operating systems, but why would you? And you can do it in SQL with set level operations that compare tables. Right, ETL. This is, I talked about collecting the history. So you've got a record in your data warehouse, you've got a new one that's come in, so you want to end date the old one and create a new one with the start date of the same date. That's what this is doing. It's called a type 2 slowly changing dimension, but basically that's what it is. It's just capturing changes. And this is in SSIS, which somebody kindly put on the internet, as you can see from the link. It could be Informatica, it could be Data Stage, it could be any of those programming by drawing pictures things, ETL tools, data integration tools. And it's got all these different screens. And some of them have got SQL in them. And it's very complicated. And yet, if you do it in SQL, that's all it takes. So you have one thing to find where you've got a new version of something. That's what this bit's doing inside there. And then setting the old record with an end date, a valid to date as the current date. And then you insert the new ones with the valid from date as the current date and nothing in the valid to date because it's the current one, and pretty much the same selection to find the ones that have changed. Those two SQL statements do what that previous page was doing. All of it. They do all of it in just that. I think that's much easier to understand. It's certainly a lot easier to manage as part of a development system. So we use short, simple scripts. This is a real one where we're just populating one table from 3 others, I think. And we have a controlling script, which looks a bit more complicated, but basically it's just a sequence of events. You just do one thing, do the next thing, do the next thing. No branching, no looping. So no real programming. It's just do this first, then do this, then do this, then do this, all the way through. And that's how we build that, our overnight run. We have no views. I wouldn't be surprised if we get a question about that. No procedures, except maybe tiny little functions that do useful things. Like, when I was working with credit card system, we have one that did a loon check to make sure that the final digit of the credit card number matches the algorithm that you can put it through the algorithm, which tells you whether the whole number is a valid number or not. And no monsters. This thing here is part of a monster. It's much too small for you to read, but it's got bits of code in there that have been commented out with a comment on, which kind of indicates that the guy's not really sure whether that's the right answer or not, but it seems to give a plausible answer. This is what, if you know Hunt and Thomas, pragmatic programmer, that's what they call programming by coincidence. And this is part of something that's 600 lines long. We don't do that. One of the great benefits of having all these small scripts is that you can store them in a source code control system. When you need to change something, you can find the ones that need to change. It's usually 1, 2, 3 scripts maybe. Store the new version, put it in your test system. If it breaks, you can come back, you can revert to the old one, you can compare the differences. And you can do that with those kind of things. When I worked on an Informatica system, when they checked that into what they call source code control system, but it's just checking in one big lump, it took many hours, and checking it out took many hours. So the whole thing, when you wanted to do a release, it took 8 hours. Well, these things check in seconds. So it's much easier to do it this way, and it's much easier to find out where you are and what you need to change. So there are some useful tools we use. And one of them is profiling. You can buy data profilers. And in fact, I first started doing this because many years ago, I was working for one of the big telephone companies, and they had a product called Trillium, which was very good, but very expensive. And when I've started using it, I said, well, this tells me so much about the source system. I always want to use that. Went to the next place and they said, we're not spending £100,000 on that. You just work it out. So I wrote one, and if anyone's brave, they can have a copy and use it. But what it does, on the left-hand side, we've got the stuff from the database metadata. So this is database schema table, the number of rows, 2.8 million, this one, and the date we ran it. So for that table, these are the column names, the data types, the defined length, whether nulls are allowed or not, how many nulls you've got. Obviously, it's 0 if you're not allowed to have any. The percentage populated. So this particular column is only populated in 3% of the rows. So that's not very exciting. But it might be really important. And you get so all these things are calculated. You get the minimum value, the maximum value in that column, maximum actual length. So this one, 4 names, has got 50 characters, but the maximum length is actually only 41. Sometimes that's more revealing than others, but and then a couple of extra things. These are links to frequencies and patterns. So we'll look at, we'll look at this one first. One of the interesting things about doing this kind of profile is that data quality issues often, not always, but often sort to the ends of the range. So I'm not promising that this will find all the data quality issues. It will not, but it will highlight some. And here we've got one where somebody's date of birth is 1651. So that's obviously wrong. Here we've got 4 names, and I think this is because the old system insists on you entering a forename, but sometimes you don't know. Sometimes people make donations via SMS, and all you know is that some money's arrived and it's through an SMS donation. But if you've got to put something in, they'll put something in. So this is / / backtick is the minimum forename, and ZZ Top misspelled. Anyone remember ZZ Top? They're still going. Texas band that rock band that I first heard when I was at university, and they're still going. Anyway, 50 years later. But anyway, ZZ Top is not somebody's name. It's obviously a fake thing. So that's a data quality issue that we've got to deal with. Right, patterns. So what we do with patterns is we translate every string into every character in every string into capital A if it's an alphabetic character, 9 if it's a digit, S if it's a space. An interesting one down here is the caret for the control character. So we can see interesting things that happen with these. Like we've got 60,000 records in this table that have got 6 control characters. When I looked at them, they're just new lines. So why has 60,000 records got 6 blank lines in it? Don't know. There may be a good reason, but it's something to go and ask the users, why is it like this? Do you want it to be like this? Should we clean it up, or should we, what should we do with it? This one has a load of spaces, leading spaces. Strange. Again, it might have some purpose, but it's something we can go and talk to the users about and say, why does your data look like this? So data profiling is really helpful. So when we get, I mentioned right at the beginning, when we first copy something into the staging area, the first thing we do is profile it. Try and get some picture from this profile about what this data looks like, and give us a starting point for conversations with the users, and possibly some options for data cleaning as well. Another thing we do is, so if you write a program, if you're a programmer these days, hopefully you're using automated testing, and every time you do a new release from development to test or test to live, it goes through a whole bunch of automated tests. So you've written your tests once, and you can run them 1,000 times. You run them every time you do a release. With a data warehouse, we need to test our code as well, because you can make mistakes in SQL and do the wrong things. But we also need to test the data, because every day we're copying data from a whole load of existing systems. Where we've got here 7 different systems here, again from the based on the insurance company stuff, and those systems will change, and the people changing them won't tell the data warehouse team. They've got a lot of stuff to think about. They won't tell the data warehouse team. So we need to check for all kinds of things: unexpected values, duplicates, out of range things, missing data. And so we run, where I'm helping out at the moment, we're running about 120 tests like this at the end of every nightly load. And then we come in and look at this overall you could call it a dashboard, except that it's only got 6 different kinds of graphs on. I think dashboards have to have at least 6 different kinds of graphs. But anyway, this one tells us, is something broken? And in social media, 1 thing out of 18 went wrong, and in claims, 3 things went wrong, and in the staff system, some things a bit dodgy, but maybe not terrible. So then we can go and investigate those and see what's wrong. So we're testing the data load as well as the code that's running. Whoops. When you drill down from that dashboard into the individual factors that we're measuring, I mean, this is quite a tricky one because we're looking at the value of transactions coming into the charity every day. And the big spikes there are the direct debit run. And you can see they're big because an awful lot of people give to the charity by monthly direct debit. Sometimes things look a bit dodgy, like 2 that are close together. I think the initial run went wrong and they had to back it out and they ran it again. But the thing we're mainly looking for is, have we got to the next time for the direct debit run and it's not there? And that's happened a couple of times. And our numbers are going to be seriously wrong if we've got that wrong. So we can't tell how much money is going to come in each day. It's quite a big variation, but we can see if the pattern looks wrong and see if, and that gives us an early warning if there's some kind of problem. There are all kinds of ways you can use these charts to actually highlight to you if something's wrong. I mean, the coloring here is actually derived from the previous, we're running 2 years here, from the previous 2 years data about what is normal and what isn't. And red means it's right on the edges of the normal distribution. And if you've got something there 3 standard deviations away from the mean, then you'll get about 1 of those a year. This was, in fact, was just a particularly good income day. And it wasn't wrong at all, but it was exceptional. So it was worth looking at to see what had happened. Right, so you can drill down from those to the actual values. And that was plotting changes from one day to the next, where you've got very variable data that can help to kind of even it out a bit. So you can drill down to that. Right. Near the end, so we'll have some time for questions. So there's a great book called Small Sharp Software Tools, which is actually about the tools that come with Linux that you can use, and it's great. We love it. We use those things. It seemed appropriate to what we try to do with the tools that we use. And the words on the left are things that are, I think, are essential. The icons on the right are my current favorites. So I would say for this kind of project, you really do want to have a wiki, and you want the whole team, the extended team, the users as well, to feel free to go in and edit that. If we describe their process and they say, no, that's wrong, and they say, well, do you want to tell us and we'll fix it, or do you want to fix it yourself? Then they can go in and edit it. And that's how we get 450 pages of really useful documentation. The one we use is Track. It's free. I like it. There are lots of others. Linux, I'm less easygoing about that. I have used Windows Server. I don't think I've used Windows Server for I've used Windows Server for lots of things. I don't think I've ever used one for a data warehouse, and I don't want to. I want Linux for big server-side stuff. Database, there are lots of good SQL databases. Well, there's a handful of good ones that can handle the volume and do it reliably. We're using Postgres at the moment, and that's my favorite. I've used it a lot. I've used products derived from it. I think Snowflake is derived from Postgres. Netezza certainly is. Yugabyte certainly is. It's a really kind of solidly engineered open source thing. So people use that to build other relational databases from. So, and it's free. I mean, those derived ones aren't free because they've added some value to it, but standard Postgres, including text searching and geospatial stuff, is free. And it can handle huge databases. Skype used to run on Postgres until Microsoft got it and said, oh, we can't have one of our products running on Postgres. The marine traffic database, which handles 500,000 ship movements a day, 6 million users a month, that runs on Postgres. So the fact that it's free doesn't mean it's not any good. It is actually very, very good. That's why I like it. Source code control, most people use Git. For small projects, I prefer Subversion because Git was designed for the massively distributed development of Linux. People all over the world are contributing to that, and that's what Git's aimed for. If you've got a smaller, more contained project, then you can use Git, and I have done, and it's fine. It's a good product, but I actually prefer Subversion for this kind of thing. All of those top 4 are free. I use a Mac, and there's a really good text editor called TextMate that I use, but a plain text editor. I mentioned The Pragmatic Programmer by Hunt and Thomas. Wonderful book for programmers. Everyone should read it. And they have a whole chapter called The Power of Plain Text. And I saw at a conference recently someone talking about testing and was just showing how there are a lot of things you can do with plain text that you can't do with a kind of whizzy drag and drop kind of interface. So those kind of things have their place, but you can do an awful lot with plain text. And if you've got a good editor, you can do even more. Procedural language, there are lots of good procedural languages, Ruby, Python, and people tell me others are good. I haven't used them all. Some of the old ones I've used, I wouldn't use again, like COBOL and so on. But Java is my favorite, but you don't have to use that. If you want to explore these tools, you can. I hope to make them properly open sourced eventually, but in the meantime, you can download them and there's a bit of documentation and you can make them work. So they're there if you want them. And that's it. So hopefully you've got some interesting questions. I'm sure you want to challenge me on some of the things I've said. But this is something that has been made to work in a number of organizations over the last few years. And so I commend it to you. Anyway,
thank you, Ron.
I'm ready for questions.
So Ron, just a message to everybody listening. If you put your questions into the chat now, I'll go through them in order. So we've had a couple have already come in. So the first one was, I wondered how backup in a data warehouse works and how the approach is different from operational database backup methods.
Well, you do, obviously you do need backups. It depends on the one we've got at the moment, which is, I said it's got 2 million supporters, 80 million transactions, 80 million correspondence records of where we sent emails to people and got replies and all that kind of stuff, and 270 million records altogether. That is backed up. We use a service for our Postgres database and they back that up for us. So that is quite manageable. Now, I worked for, I mentioned the payment card company. They had 30 million transactions a day. That's 1 billion a month. They've been growing, but their 7-year history, which they wanted to, well, they need to keep, financial records you normally need to keep 7 years, was 56 billion records. They used a distributed system. They used a data lake. Hortonworks as it was then. It's been taken over now, but still the same thing. Hadoop-based thing. And that keeps a number of copies of everything. So if you lose a whole server, you've still got all of your database. And so that as an approach for security of your data in a very large system is okay. I wouldn't recommend using a Hadoop-based system though, because that was horrible and very expensive, and actually didn't work all that well. So the Netezza I mentioned, unfortunately, IBM bought that and they seem to have killed it because it was a brilliant system. That did a similar kind of thing. Every time you stored something, you stored in 3 places. And you had a whole rack, or a few racks of processors with their own disks. And every time you wrote something in the database, it went to 3 of them. And every now and again, after we'd been running it 5 years, every now and again, one of these units, the red light would come on, it would fail. And the Netezza system would take care of that and just carry on running, but also call out the engineer. He'd come along, unplug it, plug a new one in, and it would all resync again. So that kind of distributed approach for saving you having to do a complete backup is a promising way if you've got very, very large data. But you can, most organizations would now be able to back up their whole data every night, and it wouldn't be prohibitive.
Thank you. Okay, so any last questions in the chat, please? The next question was, would you consider using a database such as Postgres on a platform such as Microsoft Azure?
Yes, we do, actually. So we buy a service which, and we did this when we started and we thought it would just be temporary, but it's just proved to be economical and reliable, so we just carried on with it, where there's an organization that installs the Postgres system for you, gives you a certain amount of disk space, and you can go up to pretty big systems, and also give you more powerful CPUs and more memory for the size of the database and the number of users. So you can configure all that for them, say what you want, and then they say, where do you want it to run? So you can run it on AWS or you can run it on Azure, and ours runs on Azure because the place I'm working is a Microsoft site. All their Office stuff, all their front-end stuff is Microsoft. But this is a Linux Postgres system running on Azure, and it's perfect. It hasn't let us down.
Okay, so there are no more questions unless anybody wants to put some last ones in the chat. So thank you very much, Ron.
Okay.
Oh, one last question. They're coming in now.
Okay, that's fine.
What are your thoughts about Snowflake?
I don't have any direct experience of Snowflake, which I regret a bit, but I just haven't come across it. But I do have 2 very good friends who've worked with me on different data warehouse projects over the years, and they're both big fans of Snowflake. They are users of Snowflake. All I can say is, from what I know, it seems to be pretty good, but I haven't used it personally. So.
I mean, similar questions about AWS Redshift and AWS Athena. Cloud database data house tooling.
I think Redshift might be based on Postgres, but it depends how much they've changed it. And again, I haven't used it personally. So what I would always want is a standard relational database. So something that at least, and none of them stick exactly to the SQL standard, but they're all pretty close, and it's very easy to move between Postgres, MySQL, Oracle, Microsoft SQL Server, Sybase SQL Server, which is now owned by SAP, IBM DB2. those all support the important relational functions. I've recently come across the Microsoft Dataverse, which is interesting because they've got SQL Server. That's a good solid database. I've seen some really good big systems running on that. But with their Dataverse, they've messed about with it, and I don't understand why. They've made it, as far as my experience of it, because I have had to deal with this thing as well, is it's not as good as the database they based it on. So I would try and stick to something that is has a good standard relational database at its core and has those main principles that a relational database does. You might have some with extra things that are, some are better at inverted indexes on text, column-based stories, they call it, but we used to call it inverted indexes. And some are better at geospatial stuff, and some have got more extensions for bigger objects, although I'm not convinced of the benefit you get by putting those in a database, because it's just a lump and you have to take it out of the database to do something with it generally. Yeah, so I would try and get something that's got solid relational database capabilities. And the ones I know are the ones I've mentioned I've worked with, DB2, Oracle, both versions of SQL Server, Postgres, MySQL, MariaDB. So all of those are fine.
So if you've got time for one more question, Rod, and it's quite a long one, do you have access to the chat?
Do I?
I mean, I can read it to you.
It looks like it.
It's a paragraph. So it's 1930 from John A. I don't know if you want to scan that first.
Okay, I'll have a look at that. Yeah, I see it. Right, that's a good question. Changes during the building of this thing are essential. Obviously, as you get more established stuff, then the costs of change can increase. I think you can always add columns to a relational database. You need to make sure you're adding them in the right place. And generally, by the time you get to something that's operational, then either the relationships between tables aren't going to change, or if you've got something that's that big of a change, then you're going to have to change the reports anyway. I think it's right that the more you get built on top of it, the more difficult it is to change things. But you have to weigh up, if you allow compromises to go in there and do things in a way that you aren't quite right for the way your data is now, then it's going to cost you more later on. So it's going to be a difficult balance, but I'd always try to get it changed. And if you keep the pieces small, then it is easier to change. Now, there was a second point there. Right, history retained in the source systems. Reloading is a scale thing, really. So where I'm at the moment, we could reload everything overnight. We'd have a lot if we made a big change, we'd obviously have a lot of testing to do, and we need a a separate track from the production one to be able to take through the test and make sure that everything still works. But the actual reloading won't be terrible. The payment card company I worked at, it used to take 3 or 4 days to load all the transactions. So if you've got something that affects that, then it's going to be very, very expensive. And it's going to be a balancing act. But when you do compromise, you pay for it later. I mean, this is the main reason that we're changing this 25-year-old system at the charity, is because it still works, but it's just got more and more workarounds in it. It got more and more difficult to use. So it's a tricky balance. There isn't one answer. So those are really important things to take into account. But I would always try to keep up with the changes as far as practically possible. Try and find a way to keep it up to date. So you either pay for it now or you pay for it later. I hope that helps.
Okay, thank you, Ron. So just to let everybody know that eventually we've been recording this presentation, and eventually it will be available on YouTube, and we'll send out a link to everybody to our member groups. And just once again, on behalf of the collaborative groups on the BCS, thank you very much, Ron, for entertaining us this evening. It's been look through the chat before you leave, because there's been some wonderful comments on this project. Okay.
Good. Thanks very much. Thank you. Thank all of you.
Thank you very much.
Questions.
Thank you, everybody.
Thank you.